So here second one, that is under the examples list, the second one is of 3x square minus 7x plus 2 is equals to 0. We have to find out the nature of the roots of this particular quadratic equation. So solution starts now. So here, as per the problem, the quadratic equation which is given for us is of 3x square minus 7x plus 2 is equals to 0. That implies, since it is in the form of a quadratic equation, the gen form is of ax square plus bx plus c is equals to 0, which is nothing but the general form of quadratic equation. Now here let us compare. X square coefficient is of a, here x square coefficient is of 3, x coefficient is of b, x coefficient is of minus 7, c is of 2. So here by comparing we can write a as 3, b as minus 7 and c as 2. So here by comparing, we can write the values of a, b and as well as c as in this manner. Then now, so here, but we know that delta, that is discriminant, is given by means of b square minus 4ac. So here delta is equals to b square minus 4ac. In order to find out the nature of the roots, so we have to find out the delta value. B square, b is of minus 7, so minus 7 whole square minus 4 into a value is of 3 into c value is of 2. So that equals to, or that implies, minus repeatedly multiplied twice. So minus of minus is plus, 7 square, 7 sevens is of 49 minus 4 threes is of 12, 12 twos is of 24. So that implies 24 is of negative and 49 is of positive. So for the further simplification, we have to, plus of minus is minus, we have to subtract the greater minus least, 49 minus 24. So from 49 we have to subtract 24. So here 9 minus 4 is of 5 and 4 minus 2 is of 2. So 25. To assess the sign here among 24 and 49, 49 is greater. So here 49 sign is of positive. So it assesses the sign of positive. So now, but it is a perfect square. 25 can be written as 5 square. So it can be splitted as 5 into 5 or can be written as 5 square. So here therefore it is a PS. PS indicates the perfect square. So 25 is a perfect square. Therefore delta value is a perfect square. So therefore, so here delta is equals to 25, which is a perfect square. Hence, that is b square minus 4ac value is equals to 25, which is greater than 0. So 25 is greater than 0. So we can write it as b square minus 4ac. Instead of delta, I wrote it as b square minus 4ac. So here b square minus 4ac is greater than 0. So here since delta, so here is greater than 0, hence since delta is greater than 0, hence the roots are real, unequal, and since it is a perfect square, we can write it as the rational. So here the roots are of real, unequal and as well as the rational, since the discriminant value is of greater than 0. Then now let us go for the case number 3. So that is the third problem, is of x square minus 10x plus 25 is equals to 0. So solution starts now. So here in our solution, as per the problem, so here as per the problem, the equation which is given is, so here x square minus 10x plus 25 is equals to 0. So that implies, since it is in the form of a quadratic, so the gen form of quadratic is ax square plus bx plus, so which is nothing but the gen form of quadratic equation. By comparing, so here write it as x square coefficient is of a, x square coefficient is of 1, a equals to 1. So here b is the coefficient of x and b minus 10 is the coefficient of x. Therefore b can be replaced by means of minus 10. So here c constant is of 25. So here c is equals to 25. Therefore by replacing these values, discriminant, but delta is equals to b square minus 4ac, which is the discriminant value. So that is equals to b square, b value is of minus 10. So minus 10 whole square minus 4 into a is of 1 and into c is of 25. So that is equals to minus repeatedly multiplied twice. So minus into minus is of plus 10 square, 10 tens is of 100, minus 4 ones is of 4, 4 into 25 is of 100. So minus 100 and plus 100 will be gets cancelled, that is equals to 0. So in this manner we got delta as 0. So here therefore delta is equals to 0. So but delta is equals to b square minus 4ac, discriminant b square minus 4ac is equals to 0. So here since delta is equals to 0, that is discriminant delta is equals to 0, then hence the roots are real and equal. Since the delta value is of, the discriminant value is equals to 0, the roots are of real and equal. So let us go for the fourth one. Fourth one is of x square minus 2x plus 13 is equals to 0. Solution starts now. So in our solution, so as per problem, so here the equation given us is of x square minus 2x plus 13 is equals to 0. So that implies, since this is the quadratic equation, so here the gen form of a quadratic equation is of ax square plus b. So this is the gen form of, by comparing, so here x square coefficient is of a and x square coefficient is of 1. So here so x coefficient is of b and x coefficient is of minus 2 and c value is of 13. Is of but delta, that is the discriminant, is given by means of b square minus 4ac. So it can be given by means of here b square. So here b value is of minus 2. So minus 2 whole square minus 4 into a value is of 1. So into c value is of 13. So that is equals to minus repeatedly multiplied twice. Minus of minus is plus 2 square. 2 2s is of 4 minus 4 1s is of 4 into 13. 13 4s are. So 4 3s is of 12 carry. 4 1s is of 4 plus 1 is of 5. So here plus 4 minus 52. So that equals to. So here by further simplification, plus of minus is minus, we have to subtract from greater minus least, that is 50, we have to subtract 4. So by borrowing we will be getting 12. 12 minus 4 is of 8. So here this remains only 4. Here 48, say 48, but here to assess the sign of 48, so we have to see the greater one among these two. Then now here 52 is greater than 4, its sign is of negative, therefore it assesses the sign of minus. So therefore delta, discriminant is of minus 48. Say therefore discriminant delta is equals to minus 48. So discriminant is given by means of b square minus 4ac, which is equals to minus 48, which is less than 0. So here we can write it as b square minus 4ac is less than 0. So here since b square minus 4ac is less than 0, hence the roots are of imaginary, or in other words they are said to be called as the complex roots.